You made it through another day. Whatever it held, the weight of it, the noise of it, the small disappointments, and the moments you almost forgot to notice. It is behind you now. This space, this quiet, this particular darkness you're resting in belongs only to you. There is nowhere else you need to be. Let your shoulders drop. Let your jaw unclench. There is nothing waiting for you on the other side of this moment. No task, no decision. Just the slow, reliable rhythm of your own breath moving through you like a tide, in and out. Easy, unhurried. You do not have to try. Tonight, we're going to spend some time with something that has been watching over you your entire life, even when you weren't thinking about it. Something that pulls at the oceans of your world and lights the path of every creature that has ever moved through the dark. Ancient, quiet, and closer than it seems. The moon. We'll follow it across geology and gravity, across time measured in billions of years, across mysteries that no instrument has yet resolved. There is so much to say about it, more than you might expect. If this kind of quiet is what you've been looking for, consider sharing this channel with someone else who needs it. It helps others find their way here too, one sleepy soul at a time. Now, close your eyes if you'd like, let your breathing slow, and let's begin. The moon is, on average, about 384,400 kilometers from Earth. That number is precise, but it doesn't quite fit in the mind the way a distance should. Think of it this way. If you could drive a car at highway speed, continuously, without stopping, it would take roughly 5.5 months to arrive. Not counting traffic, not counting sleep, just the long, dark road of space, your headlights reaching nothing, the silence absolute. And yet, by cosmic standards, the moon is right next door. A neighbor so close that we can see its craters with the unaided eye. We can watch the shadow of our own planet slide across its face. It is, in the vocabulary of the universe, practically touching. The moon formed about 4.5 billion years ago. The leading theory, the one most scientists have come to accept, though accept is perhaps too confident a word, is that a Mars-sized body collided with the early Earth. Not a gentle collision, a catastrophic one. The debris from that impact, a ring of molten rock and vaporized material, gradually coalesced into the sphere we now call the moon. Everything about you, the planet you were born on, the gravity that holds you to your bed tonight, was shaped by that ancient violence. And now it is so quiet. The moon has no atmosphere worth speaking of. There is a thin, fragile layer of gas, technically called an exosphere, but it is so tenuous that a single breath of it would contain almost nothing. No wind, no weather, no sound. A footstep on the lunar surface produces no crunch, no echo, only the dull compression of dust beneath a boot. 12 human beings have walked there. Each one experienced a silence so complete it had its own texture. They described it differently, but the silence was always the first thing they mentioned when they came home. Because the moon has no atmosphere, there is no protection from the sun's radiation, and no air to distribute heat. On the sunlit side, temperatures can reach 127 degrees Celsius. On the dark side, in the shadow of a crater wall, they can plunge to negative 173 degrees. Both extremes exist simultaneously, separated sometimes by only a few meters. The moon does not average its temperatures the way Earth does. It simply holds them side by side in complete indifference. Even as you rest here, the moon is moving. Not in a way that would startle you, invisible. It travels around the Earth at about 3,683 kilometers per hour, faster than any aircraft in regular service. And yet from where you lie, it seems to drift, to hang, to merely be. Perception is strange that way. The things moving fastest are often the ones that look most still. The moon is tidally locked to Earth. This means it rotates on its own axis at almost exactly the same rate that it orbits our planet. One rotation per orbit. The result is that the same face of the moon is always pointing toward us, the far side, which some people call the dark side, though that name is technically inaccurate since it receives as much sunlight as the near side, has never been seen from Earth with the naked eye. Not once in human history. Every cave painting, every myth, every longing gaze upward at the night sky, all of it directed at the same hemisphere. The other half remained entirely unknown until a Soviet spacecraft photographed it in 1959. The far side of the moon is different from the near side in ways that still puzzle scientists. It has fewer of the dark basaltic plains called Maria, the seas that ancient astronomers named, mistaking them for water. It has a thicker crust. It is cratered more heavily. The two faces of the same body are geologically distinct in ways that a simple accident of orientation shouldn't explain. Theories exist. Simulations have been run. And yet the reason remains, in the end, not quite settled. Something happened to the moon that we still don't fully understand. That, too, is a kind of comfort, to know that even the familiar can hold its secrets. Right now, as you breathe, the moon is exerting a gravitational pull on you. Not enough to feel, not enough to matter in any practical sense, but real. Every atom in your body has a slight, almost immeasurably small lean toward it. The same force that lifts the oceans, the same invisible hand that has guided ships and birds and the spawning of horseshoe crabs for as long as the moon has circled this world. It reaches through walls, through ceilings, through the dark between stars, and touches you where you lie. The moon's gravity is about 1/6 that of Earth's. If you stood on the lunar surface, which is itself a strange thought, to imagine yourself there in a pressurized suit, your own breath visible in the visor, you would weigh roughly 1/6 what you weigh right now. An 80-kilogram person becomes 13 kilograms. You would move differently. Bounce, almost even trying to walk normally. The astronauts discovered that the most efficient way to cover ground on the moon was a kind of loping skip, pushing off gently with each step and allowing the low gravity to carry them forward. It looked almost playful from the footage, but they were working carefully, aware of how far from home they were. The footprints left by the Apollo astronauts are still there, undisturbed, with no wind, no rain, no geological activity of the kind that reshapes Earth's surface constantly. There's nothing to erase them. They will remain for millions of years, gradually degraded only by micrometeorite impacts and cosmic radiation, softened by millimeters over vast stretches of time. Buzz Aldrin's boot print, pressed into the lunar regolith in July of 1969, will outlast every human institution currently in existence. It will outlast the names we have given things. It will still be recognizable, in some form, when the continents you live on have shifted into shapes no map has yet imagined. The lunar surface is covered in a layer of fine, powdery material called regolith. It is not soil in any sense that a gardener would recognize. There is no organic matter, no worms, no bacteria, no humus accumulated from generations of falling leaves. It is ground up rock, shattered over billions of years by impacts large and small, mixed with glass beads formed when meteorite strikes melted and re-solidified the surface. The astronauts who walked in it said it smelled once they returned to the lander and removed their helmets like gunpowder or spent fireworks. The first human being to smell moonlight described it this way, and no one has really improved on the description since. The moon experiences moonquakes, not metaphorically, literally. Seismometers left by the Apollo missions recorded seismic events, some shallow, some deep, that continued for decades after the instruments were placed. The moon shakes. The reasons are varied: tidal stress from Earth's gravity, the thermal expansion and contraction of the surface during the extreme temperature swings of the lunar day, and possibly some residual geological activity from a core that is not entirely dead. Moonquakes tend to be smaller than major earthquakes, but the deep ones can last for extended periods, sometimes up to an hour. Earth's earthquakes release energy and stop. The moon, with less internal damping, can ring like a bell. Deep in the shadowed craters near the moon's poles, there is water ice. It arrived over billions of years, carried by comets and asteroids, sheltered from the sun in places where sunlight has never reached. Some of these permanently shadowed regions have not seen direct sunlight in 2 billion years. They are among the coldest places in the solar system, and within them, frozen and waiting, is water that may one day sustain a lunar outpost, that may one day be split into hydrogen and oxygen for rocket fuel. The raw material of the future, sitting patiently in the dark. Even as you lie still, the moon is slowly drifting away, about 3.8 centimeters per year. Not a dramatic retreat. You would need geological time to notice it, but it is measurable, precise. Verified by laser ranging experiments that bounce beams off reflectors left on the surface by Apollo astronauts. Every year, the moon is slightly farther than the year before. Early in Earth's history, it was much, much closer. Perhaps 10 times closer. The tides it raised would have been towering. The nights it lit would have been bright enough to see color by. And it is leaving, slowly, incrementally, the way all things eventually do. You are made of elements that were forged in the cores of stars. So is the moon, the oxygen in your blood, the calcium in your bones, the iron that makes your blood red. These were synthesized in the nuclear furnaces of stars that died billions of years before the sun was born, before the Earth was formed, before the moon was torn from the young Earth's side. You and the moon share an ancestry that is not metaphorical. It is chemical, elemental, written in the same periodic table. The moon has mountains. The lunar Apennines rise to about 5,000 meters, comparable in height to the Alps. They were formed not by tectonic collision, as mountain ranges on Earth are, but by the impact that created the Mare Imbrium Basin. The rebound of that ancient, enormous collision pushed rock upward into ridges that have stood unchanged for over 3 billion years. Mountains that have never been eroded by rain, never climbed, never photographed from a hiking trail. Just standing there, patient and cold and perfectly still. There are valleys on the moon too. Sinuous rills, long, winding channels that look, at first glance, like ancient riverbeds. No water carved them. They were formed by lava flows in the moon's more active volcanic past, when tubes of flowing magma collapsed or cut channels into the surface. The moon was once volcanically active. It was once a world that poured its interior out onto itself, building plains and filling craters with dark basalt. That era ended. The fires cooled. And now it sits in silence. The memory of its volcanic past preserved perfectly in a landscape that changes by almost nothing. The moon has no magnetic field to speak of, not now. But evidence suggests it once did. Some lunar rocks are magnetized in ways that imply the moon once had a global magnetic field, probably generated by a molten, convecting core, the same process that gives Earth its protective magnetosphere. That core cooled, the dynamo stopped, the field faded, and the moon lost the protection it once had, left exposed to the solar wind ever since. How long the field lasted, and how strong it was, are questions that are still being worked out. Right now, as your breathing slows, the moon is above the horizon for half of the Earth. Someone on the other side of the planet from where you lie is looking up at it. Perhaps a fisher on a small boat, reading the light on the water. Perhaps a child who woke from a dream and wandered to the window. Perhaps someone who is not thinking about the moon at all, simply walking home, their face briefly illuminated. The moon does not choose. It shines on everyone equally, without preference, without memory. The moon's surface gravity, combined with its lack of atmosphere, means that any object launched from the surface at about 2.38 kilometers per second will escape the moon entirely. This is the lunar escape velocity. It is much lower than Earth's. If you could throw a baseball at exactly that speed on the moon, it would leave the moon forever. It would drift away into the solar system and become, eventually, just another piece of rock orbiting the sun, thrown from the surface of the world. Gone. The Lunar Maria, the dark plains that cover much of the near side, were formed by ancient volcanic eruptions between 3 and 4 billion years ago. Lava flooded the interiors of enormous impact basins, cooling into the flat, dark expanses we see today. The largest of them, Oceanus Procellarum, the Ocean of Storms, covers about 2.5 million square kilometers. It is larger than the Mediterranean Sea. Ancient astronomers, looking up without telescopes, saw these dark regions and named them seas, believing they might hold water. They do not, but the names remain. Sea of Tranquility, Sea of Serenity, Sea of Rains. Names that were wrong about the facts and right about the feeling. The moon does not generate its own light. Every photon of moonlight you have ever seen, every night you navigated by it, every reflection on a lake, every shadow it cast across a bedroom floor was sunlight, reflected, bounced off a surface of dark rock and pale dust and sent on its way to your eyes. The moon, for all its brightness on a clear night, reflects only about 12% of the sunlight that strikes it. It is, technically, about as reflective as worn asphalt. And yet it feels luminous. It feels like light coming from a source, not a mirror. The brain insists on it. Even now, as your mind begins to quiet, the moon is pulling on the Earth's crust. Not just the oceans. Solid land rises and falls by a few centimeters twice a day under the combined pull of the moon and sun. It is called the solid earth tide. The ground beneath your bed is moving, gently, predictably, without drama, with a period of about 12 hours. You cannot feel it. The motion is too slow and too uniform, but the GPS satellites can detect it. The instruments know. The Earth is breathing too. The crater Tycho is one of the most striking features visible from Earth. A circular scar about 85 kilometers in diameter, with a central peak that rises nearly 2 kilometers from the crater floor, and rays of ejected material that extend for hundreds of kilometers across the lunar surface. When you look at the moon near full phase, Tycho is the bright spot near the south, the one that seems to glow. It was formed about 108 million years ago, which sounds ancient and is, by human measure, but is geologically recent for the moon. The dinosaurs were still alive on Earth when Tycho was made. The moon orbits Earth at an inclination of about 5 degrees to the plane of Earth's orbit around the sun. If the moon's orbit were perfectly aligned, we would have a solar eclipse and a lunar eclipse every single month. Instead, the moon's tilted path means the three bodies rarely align precisely. When they do, when the sun, earth, and moon form a perfect line, we call it a syzygy, a word so satisfying to say that it seems a shame to have no use for it in daily conversation. Syzygy, the straight line of three worlds, a total solar eclipse in which the moon perfectly covers the disk of the sun, is only possible because of a remarkable coincidence. The moon is about 400 times smaller than the sun, and also about 400 times closer to Earth. These two ratios almost exactly cancel, making the moon appear the same size as the sun from Earth's surface. This coincidence is not guaranteed by physics. It is not required by any natural law. The moon could have been any size, at any distance. That the numbers work out so precisely, that the moon covers the sun so completely, so cleanly, is something that has no explanation beyond the particular history of this solar system. The moon has no seasons. Earth has seasons because its axis is tilted relative to its orbit, so different parts of the planet receive different amounts of sunlight at different times of year. The moon's axial tilt is extremely small, just about 1.5 degrees. The poles receive sunlight nearly perpetually at a very low angle, and some crater floors near the poles receive no sunlight at all, for the reasons we have already mentioned. There is no spring on the moon, no summer, no long, warm evenings. Just the slow turning of the sunlit hemisphere as the moon makes its month-long circuit. You are resting now, and somewhere above your ceiling, above the atmosphere, above the exosphere, photons are arriving from the sun at the speed of light, taking 8 minutes to make the journey, and some of them are striking the moon. They bounce. They travel the 384,400 kilometers back across the dark. They enter the atmosphere above you. They pass through the ceiling. They fall on your closed eyelids. Moonlight is touching your face right now if the moon is up. Old light, reflected and resent, touching you. The first person to propose that the moon might have been formed by a giant impact was not a modern scientist. The idea has deep roots, and versions of it were proposed in various forms long before the Apollo era. But the specific giant impact hypothesis, that a Mars-sized body called Theia struck the early Earth at an oblique angle, and that the resulting debris formed the moon, gained widespread acceptance only in the 1980s, following a conference where the evidence was laid out and a community of skeptics slowly arrived at a grudging consensus. Science moves slowly. It double-checks. It argues in conference rooms. And sometimes it arrives, reluctantly, at something that sounds like myth. The moon's surface features some of the oldest rock in the solar system. The lunar highlands, the pale, heavily cratered terrain that makes up much of the far side and the poles, are composed largely of a rock type called anorthosite. The Apollo missions collected samples of it that have been dated to over 4 billion years old. Earth's surface is constantly renewed, constantly recycled by tectonic activity. Nothing on Earth's surface is that old. But the moon, geologically quiet for billions of years, has kept its record. You can hold the oldest solid material ever touched by human hands, and it is from the moon. The moon influences biology on Earth in ways that are genuine, if sometimes overstated. The reproductive cycles of many marine organisms are tied to the lunar cycle. Certain corals spawn en masse on the nights following the full moon, the spawning of the grunion. Small fish that ride waves onto California beaches to lay their eggs in the sand is timed to the highest tides of the lunar cycle. The connection between the moon and life is not superstition. It is physiology. Evolution has threaded the lunar cycle into the timing of reproduction, of migration, of behavior, across hundreds of millions of years. As you settle deeper into rest, consider that the human body contains its own tidal rhythms. Circadian clocks, biological timekeepers built into almost every cell, track cycles of roughly 24 hours, synchronized by light. Some research suggests the body may also track longer cycles. The average human menstrual cycle is approximately 29.5 days, strikingly close to the lunar cycle of 29.53 days. Whether this is coincidence, convergent evolution, or something else is still being studied, the evidence is not definitive. But the similarity is too precise to dismiss without curiosity. The moon has been mapped in extraordinary detail. Orbiting spacecraft have produced elevation maps with resolution fine enough to detect features the size of a house. We know the depth of craters, the height of mountains, the chemistry of the surface, the density of the underlying rock. We know it in some respects better than we know the ocean floor. And yet there are still questions that no map answers. Why is the far side so different? What exactly happened to the moon's magnetic field? What is the precise structure of its core? Knowing the shape of something and knowing what it is are different kinds of knowledge. The South Pole Aitken Basin is one of the largest and oldest impact craters in the solar system. Located on the moon's far side, near the South Pole, it stretches about 2,500 kilometers across and reaches depths of about 8 kilometers. It was formed by an enormous impact early in the moon's history, one powerful enough to excavate deep into the lunar mantle. It is so large that, standing in its interior, you would not be able to perceive yourself as being inside a crater. The curvature of the moon would hide the walls below the horizon. You would simply be standing on a very large, very old, very quiet plain. There have been lights reported on the moon by observers over many centuries. Brief flashes, glows, and color changes on the lunar surface that are collectively called lunar transient phenomena. They are not understood. Some may be outgassing, pockets of gas escaping from the interior through fissures. Some may be electrostatic discharge, dust becoming charged and glowing faintly in the low-gravity environment near the surface. Some historical reports may have been meteor impacts, and some remain simply unexplained, things seen by careful observers with good instruments, written down and compared, that do not fit neatly into any current model. The moon keeps something back, even now. The concept of a supermoon has become popular in recent years, though it describes something that has always happened. The moon's orbit around Earth is not a perfect circle. It is an ellipse. At perigee, the moon is closest to Earth, about 356,500 kilometers away. At apogee, it is farthest, about 406,700 kilometers. When a full moon coincides with perigee, it appears slightly larger and brighter than average. The difference is real but subtle, about 14% larger and 30% brighter than a full moon at apogee. Most people, looking up on such a night without knowing, would simply feel the moon seemed beautiful. That feeling is not wrong. Right now, as you breathe without effort, the moon is one of the most studied objects in the history of science, and also one of the most personally meaningful. Every culture that has ever existed has looked up at it, named it, woven stories around it, tracked time by it, planted crops by it, made decisions by it. The moon has been a calendar, a compass, a companion, and a mystery across every civilization that has recorded its thoughts. It belongs, in some way, to everyone who has ever been afraid of the dark and looked up. The moon is the 5th largest moon in the solar system. It is larger than Pluto. It is large enough relative to Earth that some scientists refer to the Earth-Moon system as a double planet. The mass ratio between the Moon and Earth, about 1 to 81, is unusually high compared to most planet-moon pairs in the solar system. Most moons are tiny compared to their host planets. Ours is disproportionately large, and that disproportionate mass is, very likely, what makes Earth habitable. The Moon stabilizes Earth's axial tilt, preventing the wild swings that would occur on a planet without such a large neighbor. The Moon keeps Earth pointed at the right angle to the Sun, season after season, age after age. The Moon's surface is peppered with craters of every size, from microscopic pits to basins hundreds of kilometers across. The largest craters have been filled and modified, and sometimes filled again. The smallest are so tiny they can only be seen under a microscope in returned lunar samples. Tiny glass-lined pits left by the impact of particles moving at cosmic speeds. The Moon is a record of bombardment. Every impact that struck it preserved. Every scar held. Earth experienced the same bombardment but wiped most of the evidence away. The Moon kept the receipt. NASA's Lunar Reconnaissance Orbiter, launched in 2009, has been orbiting the Moon for over a decade, mapping its surface in unprecedented detail, measuring temperatures, searching for water ice, and building the data sets that will guide future missions. It has found pits, vertical shafts in the lunar surface that open into underground voids, possibly lava tubes. Some of these pits are large enough to house entire buildings. The temperatures inside are more stable than the extreme surface temperatures. They are, in concept, natural shelters. Caves on another world, waiting. The Moon rotates on its axis once every 27.3 days, exactly the same time it takes to complete one orbit around Earth. This is not a coincidence. It is the outcome of tidal locking, a process in which Earth's gravity gradually slowed the Moon's rotation over hundreds of millions of years until the rotation and orbital periods synchronized. The Moon used to rotate faster. It used to show different faces to Earth as it orbited. Gradually, inexorably, Earth's tidal forces braked it until it settled into the configuration we see now, spinning and orbiting in perfect, locked unison. The Moon could not look away. Even as you rest, satellites are measuring the Moon's distance from Earth to within millimeters. The technique, called laser ranging, works by firing a laser pulse at one of the 5 retroreflector arrays left on the lunar surface. 4 by American missions, 1 by a Soviet rover. The pulse bounces back. The round-trip time, measured to picoseconds, reveals the distance with extraordinary precision. The system has been running, with periodic interruptions, since 1969. More than 50 years of data. The Moon's gradual recession, its slight wobbles, the subtle variations in its distance, all recorded, all understood, and yet still, somehow, beautiful. Water, as we have noted, exists on the Moon. But a 2020 study using NASA's SOFIA infrared telescope found evidence of water molecules, not just in the permanently shadowed polar craters, but on the sunlit surface, trapped in glass beads within the regolith, protected from the vacuum by the structure of the glass itself. Water in the sunlight, a tiny amount, roughly equivalent to a 12-ounce bottle spread across a cubic meter of lunar soil. But they're nonetheless. The Moon is not entirely dry. It is nearly dry. But nearly, in science, is a meaningful word. The Moon's atmosphere, its exosphere, technically, is so thin that the particles within it almost never collide with each other. Each particle moves freely in a ballistic arc, like a tiny projectile, bouncing off the surface and returning to it without ever interacting with another gas molecule. This is a different kind of atmosphere than anything we experience. The exosphere is composed partly of atoms sputtered off the surface by solar wind, partly of gases released by radioactive decay in the lunar interior, and partly of material delivered by micrometeorites. It changes. It breathes in its own barely perceptible way. But you would not survive in it for a heartbeat. The moon has been visited by over 100 spacecraft from various nations, including orbiters, landers, and rovers. Only 6 of those missions carried human beings to the surface and back. 12 people in total have walked on the moon. All were American. All were men. All were between the ages of 36 and 47 when they walked there. The youngest person to walk on the moon was Charles Conrad Jr., who was 39. The last person to walk on the moon was Harrison Schmitt, a geologist, who left the surface on December 14, 1972. That was more than 50 years ago. The footprints are still there. The moon affects Earth's rotation. Tidal friction, the drag of the tidal bulge that the moon raises in Earth's oceans, is very gradually slowing Earth's rotation. Days on Earth are getting longer by a tiny amount, about 1.4 milliseconds per century. But over geological time, the effect is enormous. 4 billion years ago, an Earth day lasted only about 6 hours. Ancient tidal rhythms preserved in rock formations called tidalites, layers of sediment deposited by tides over millions of years. Let scientists calculate historical day lengths with surprising accuracy. The moon has been setting the pace of our days for as long as there have been days to set. As you breathe in the dark, think about this. The moon's gravity, right now, is stretching the Earth itself. Not just the oceans. The solid rock of the planet deforms, measurably, in response to the moon's passage. Deep underground, instruments designed to detect gravitational waves, some of the most precise measuring devices ever built, must account for this deformation in their calculations, because the Earth's shape is always changing slightly as the moon moves overhead. The planet you are resting on is not rigid. It flexes. It responds. It leans, almost imperceptibly, toward the sky. The surface of the moon is broken into distinct geological units, mapped and classified by planetary scientists. There are the ancient highlands, the smoother volcanic maria, the ejecta blankets thrown by large impacts, the rills and ridges. Each tells part of the story of the moon's history, and embedded within that history is a record of the early solar system that cannot be recovered anywhere else. A snapshot of conditions 4 billion years ago, preserved because the moon stopped changing. The moon is, in this sense, a time capsule, a hard drive that has not been overwritten. There is a feature on the moon called the straight wall, rups recta in Latin. It is a linear scarp, a cliff of sorts, that runs for about 110 kilometers across the surface of Mare Nubium. It drops about 240 to 300 meters on one side. When the sun's angle is low and the shadows are long, it appears as a stark, perfectly straight line across the landscape. Something that looks almost intentional, almost architectural, in the natural chaos of the lunar surface. It was formed by faulting, the same process that creates cliffs on Earth. But on the moon, without erosion, it remains sharp, clean, precisely itself. You are made of calcium. So is the moon, in part. The lunar highlands are rich in calcium feldspar, an orthosite, the pale rock that makes the mountains bright. The calcium in your bones traces its origin to stellar nucleosynthesis, the same process that filled the early universe with the raw materials of the moon's crust. You and the moon are not just neighbors. You are distant relatives, sharing an element that was forged before either of you existed. The universe is not as empty of connection as it looks. The moon has inspired timekeeping since long before anyone built a clock. The word month comes from moon. Many ancient calendars, Jewish, Islamic, Chinese, Hindu, and many indigenous calendars around the world, are lunar or lunisolar, tracking time by the visible cycle of the moon's phases. The moon was the first calendar. The new moon was the middle page. The full moon was the middle. The waning crescent was the ending. People built their planting seasons and their religious observances and their festivals around these cycles for tens of thousands of years. We still do, in ways we sometimes don't notice. The moon's near side and far side have different average crustal thicknesses. The near side crust averages about 30 to 40 kilometers thick. The far side crust averages about 50 to 60 kilometers. This asymmetry is one of the most puzzling features of the moon. It influences the distribution of volcanic maria, the location of large impact basins, and the overall shape of the moon, which is slightly asymmetrical, with its center of mass offset from its geometric center toward the near side. The moon is not a perfect sphere. It is not even a perfect oblate spheroid. It is its own particular shape, subtly lumpy, pulled and pressed by history. There is a group of scientists who study something called lunar swirls, mysterious bright patterns on the moon's surface that appear in association with localized magnetic anomalies. These are not depressions or raised features. They are patterns in the dust, in the regolith, somehow preserved and associated with magnetic fields that are not linked to the moon's overall absent global field. Their origin is debated. One hypothesis suggests they were formed by the impact of cometary material, which magnetized the rock locally and shielded the surface from the solar wind in a way that preserved lighter colored dust. Another suggests ancient volcanic processes. We still don't know. The moon offers its swirls without explanation. The Apollo 11 mission, which landed the first humans on the moon on July 20th, 1969, carried a 3-person crew: Neil Armstrong, Buzz Aldrin, and Michael Collins. Collins remained in lunar orbit aboard the command module while Armstrong and Aldrin descended to the surface. He orbited the moon alone, on the far side, completely out of contact with Earth or his crewmates, for about 48 minutes of each orbit. More alone, arguably, than any human being in history. More than 2,000 kilometers from the nearest other people, and separated from them by an entire world. He later described the experience as not lonely, but rather as exquisite solitude. He seemed at peace with it. The moon produces very faint natural luminescence. When cosmic rays strike the lunar surface, they occasionally produce faint flashes, so faint as to be essentially invisible, as the energy is deposited into the regolith. The moon also has a very faint thermal glow in the infrared, radiating back the heat it absorbed from the sun. And there are reports, still not fully explained, of very faint visible glow from the surface in certain conditions. Not moonlight, not reflected sunlight, something else. Faint, rare, possibly real. The moon glows in ways that instruments only barely catch. As you lie here, your nervous system is slowing. Your heart rate is dropping. The cortisol in your blood is tapering off. These are ancient processes, not learned, not chosen. They happen because you are an animal, and animals need sleep, and sleep has its own ancient chemistry. The moon helped set the conditions for this sleep by stabilizing Earth's tilt, by moderating the tides, by providing the cycling light that organisms threaded into their biology. The moon helped create the conditions in which your kind of life was possible. You sleep under the moon's influence in ways more fundamental than you can feel. the surface of the moon is electrically charged, the solar wind. A stream of charged particles from the sun strikes the daylit side of the moon and gives it a positive charge. The night side, shielded from the solar wind but struck by energetic electrons from the broader magnetosphere, becomes negatively charged. At the terminator, the line between day and night, the transition between these charges creates unusual electrostatic conditions. Dust on the lunar surface can become electrostatically levitated, floating above the ground, drifting at the terminator. Scientists have proposed that this floating dust might even produce a faint horizon glow, occasionally glimpsed by orbiting cameras. The moon hovers in its own quiet electrical field. The moon is not fully geologically dead. We know from seismometers that it shakes. We know from analysis of young geological features that some activity persisted to perhaps 1 billion years ago. And in 2019, researchers analyzing data from NASA's Lunar Reconnaissance Orbiter identified features they interpreted as evidence of recent, geologically recent, meaning within the last 100 million years, tectonic activity. Thrust faults that suggest the moon's interior is still contracting slightly as it cools. The moon is not frozen. It is cooling, still, slowly, releasing the heat it formed with. In the language of geology, it is not finished. There are mountains on the moon that have never cast a shadow. Near the lunar poles, certain mountain peaks exist at elevations high enough, and at latitudes close enough to the pole that they receive sunlight almost continuously, for months at a time, as the moon orbits and the sun's angle slowly shifts. These are called peaks of eternal light. The name is an exaggeration. There is no truly eternal sunlight, but they are among the sunniest places in the inner solar system. They sit beside the darkest places. Light and dark, permanent neighbors, separated by altitude. When astronauts stood on the moon, they could see the stars far more clearly than from Earth's surface. With no atmosphere to scatter the light, the stars were steady and fierce. And yet, while standing in the sunlit lunar day, the sun was so overwhelmingly bright that the sky was black around it. No blue sky, no diffuse glow, just the sun, harsh and white, in a black sky full of stars. The stars that have always been above you are always visible on the moon. Nothing hides them. The last time a human being set foot on the moon was December 14th, 1972. Harrison Schmitt and Eugene Cernan were the final two. Cernan was the last to climb back into the lunar module, and as he left the surface, he said, "We leave as we came, and God willing, as we shall return, with peace and hope for all mankind." That was more than 50 years ago. The hope has not yet returned, but it has not been abandoned. And the moon has been waiting with the patience of something that measures time in billions of years. The Chinese National Space Administration landed a rover, Yutu-2, on the far side of the moon in January 2019. The first soft landing on the lunar far side in history. It required a relay satellite called Queqiao, positioned at the L2 Lagrange point beyond the moon, to maintain communications with Earth, since the far side faces away from us and cannot transmit directly. The rover has been operating far longer than its design lifespan, traversing the ancient terrain of the Von Karman crater, sampling regolith, and sending back the first close-up images of a surface that no human eye had ever seen from the ground. It moved slowly, carefully, like something that understood how far it was from home. The moon has a very slight bulge on the side facing Earth, a tidal bulge permanently frozen in the rock, a relic of the time when the moon was closer and still rotating, and the tidal forces were stronger. Today, that bulge is locked, pointing always toward Earth, a permanent reminder of the moon's younger, more active, closer past. If you could stand at the exact point on the moon closest to Earth, you would be standing on that fossil bulge, closer to Earth by a few kilometers than the average lunar surface, standing at the top of an ancient tide. Even as you breathe, you are moving. The Earth rotates at about 1,670 kilometers per hour at the equator. You are being carried through space at this speed without feeling it. The Earth orbits the Sun at 107,000 kilometers per hour. The solar system moves through the galaxy. The galaxy moves through the local group. You are never still, and neither is the moon. It orbits, it rocks slightly in a motion called libration, it tilts, it is pulled. Everything is in motion. Rest is something you carry with you through all of it. The word lunacy derives from the Latin word for moon, luna. For centuries, it was believed that the full moon caused erratic behavior, madness, and disturbed sleep. The belief was widespread enough that it was codified in law in some jurisdictions, with judges permitted to take the lunar phase into account when assessing criminal behavior. Modern research has mostly failed to find robust evidence for this effect. Studies on psychiatric admissions, crime rates, and sleep disturbances have generally not supported the lunar connection, and yet the belief persists. The moon carries the meaning we gave it. It carries more than its share of our projections, our fears, our need to find a pattern in the light. The moon is slowly teaching Earth a lesson that has been ongoing for 4.5 billion years. Through tidal friction, it is transferring angular momentum from Earth to the moon. Earth slows, the moon drifts farther. Energy is conserved, the system evolves. This will continue until, in the far distant future, billions of years from now, Earth's rotation will have slowed enough that it matches the moon's orbital period, and the moon will stop receding. The two bodies will be tidally locked to each other. The moon will always be above the same point on Earth's surface, permanent, immovable, a final stillness between two worlds. There is a school of thought in planetary science that suggests the moon was instrumental in the development of life on Earth, not just by stabilizing the axial tilt, but by contributing to the tidal pools where early life may have concentrated and complexified. The intertidal zone, that strip of shore that is alternately covered and exposed by the tides, is one of the most energetic and chemically active environments on the planet. Some origin of life hypotheses propose that this zone, created and driven by lunar tides, provided the cycling of wet and dry conditions needed for early chemistry to progress. If this is right, the moon did not just witness the origin of life, it participated. You have been breathing this whole time, in and out, without deciding to, without remembering to. Your body does it, as it always has, as it always will tonight while you sleep. Billions of breaths in a lifetime, trillions of atoms passing through you with each breath, atoms that have been part of other bodies, other air, other eras. The moon has watched this happen for every human who has ever lived. It watched our ancestors breathe by firelight. It will watch whoever comes after us breathe in whatever world they inhabit. The moon does not know your name, but it has never looked away. The moon's iron core is small compared to Earth's. While Earth's core makes up about 32% of its mass, the moon's iron core makes up perhaps only 2 to 4% of its mass. This is one piece of evidence for the giant impact origin. A glancing collision with Theia would have scattered much of the early Earth's iron core material, with the debris that formed the moon being disproportionately composed of the silicate mantle material rather than iron. The moon is, in a sense, mostly Earth's old mantle. You are living on one half of a world. The other half is hanging in the sky. lunar eclipses, when Earth's shadow falls across the moon, are the most visible of the orbital geometry events available from Earth's surface. During a total lunar eclipse, the moon doesn't go dark. It turns red, sometimes a deep blood red, sometimes a brighter coppery orange. This color comes from the same physics that makes sunrises and sunsets red on Earth, the refraction of sunlight through Earth's atmosphere, which bends red wavelengths into the shadow zone. When the moon turns red during an eclipse, it is being lit by every sunrise and sunset on Earth simultaneously, all of them at once, bent into the shadow, touching the moon in red. The moon is the source of one of the most common symbols in human history: crescent, half, gibbous, full. These shapes appear in the artwork of every civilization. They decorate flags, coins, religious symbols, jewelry, and architecture across thousands of years. The crescent moon appears in ancient Mesopotamian iconography, on Islamic flags and monuments, in the horns of Egyptian goddesses. The full moon has been a symbol of completeness, madness, fertility, and transformation. The moon did not ask for this. It simply cycled, as it always had, and the humans below it looked up and saw meaning. We are meaning-making creatures. The moon offered itself, and we obliged. There are more than 300,000 craters on the moon that are larger than 1 kilometer in diameter. Each one is a record of a specific event, a specific moment when something arrived from somewhere and struck the surface and released energy. Some of those moments were catastrophic, some were small, but all of them are preserved. The moon is a diary written in impacts, covering 4.5 billion years. You could spend a lifetime studying each crater's shape, depth, rays, and secondary craters, and never finish. The moon has been busy for a world that seems so still. The Apollo missions brought back 382 kilograms of lunar rock and soil. These samples are some of the most carefully curated materials on Earth. Most of them are stored in nitrogen-filled containers at the Lunar Sample Laboratory Facility at NASA's Johnson Space Center in Houston, protected from contamination by Earth's atmosphere and biological material. Some were intentionally set aside, sealed and untouched, for future scientists with better instruments. About 15% of the Apollo samples have never been opened. They are waiting for us to be ready. We are still working on being ready. The moon is about 1/4 the diameter of Earth. If Earth were the size of a basketball, the moon would be roughly the size of a tennis ball. This sounds small, but hold both in your mind at once and feel how large the moon is in comparison to everything else in your life. The moon is 3,474 kilometers across. It is wider than the continental United States from coast to coast. At the right angle and altitude, it would cover most of what you think of as the sky. It is not small. It is simply far. Moonbows, rainbows produced by moonlight rather than sunlight, exist. They are faint, almost always appearing white to the human eye because moonlight is too dim to activate color perception. But photographed with long exposures, they reveal color. They appear near waterfalls, in mist, in the spray of large waves. They are rare and gentle, and caused by the same physics as the vivid arcs of a summer afternoon. The moon creates rainbows. It creates them quietly, in colors we can barely see. That seems exactly right. You are small, not in a way that diminishes you, in a way that holds you. The moon is large enough to create rainbows and tides and eclipses and the rhythms of biology. The universe is large enough to contain millions of moons. You are one living body on one world, in one solar system, in one arm of one galaxy, among hundreds of billions. And yet you are here, breathing, thinking, just barely, as sleep approaches. The scale is not a threat. It is a cradle. There is a point between the Earth and Moon, about 346,000 kilometers from Earth, where the gravitational pulls of the two bodies are exactly equal. Called the L1 Lagrange point, it is one of 5 such points in the Earth-Moon system. At L1, an object placed there would feel the same pull from both bodies. It is a gravitational balance point, a place of equilibrium. The universe has balance points built into it, places where forces cancel and stillness becomes possible, even between massive bodies. The universe provides rest, in small ways, in precise locations. Rest is a real thing in the physics of the cosmos. The moon's libration, its gentle rocking motion as seen from Earth, allows us to see slightly more than 50% of its surface over time. Because of the moon's elliptical orbit, it moves faster when closer, slower when farther, and its slight axial tilt, it appears to rock slightly north-south and east-west over the course of each month. In total, about 59% of the moon's surface is visible from Earth at one time or another. Not 50, not 100, 59. A little more than half, offered to the eye of a careful observer willing to watch over many months, catching the moon at different angles in its rocking, patient circuit. The moon has been humanity's companion through every chapter of our story. It was above the first migrations out of Africa. It lit the routes of the first ocean voyagers navigating by stars. It waxed and waned over the construction of every monument, every temple, every city. It has seen every war begin and end. It saw the extinction of the mammoths. It has watched the ice ages advance and retreat. It has seen the Mediterranean basin fill with water, seen the Sahara green, and then desert, and then green again. And now it sees you, small and warm in your bed, at the edge of sleep. The moon is the only other world where human footprints exist. Everywhere else, Mars, Titan, the asteroids, we have sent machines. Sophisticated, extraordinary machines, but machines. The moon is the only place beyond Earth where a human being stood, turned, looked back at the blue world, and breathed. The only place where a human voice has been heard in the vacuum, in the helmet, in the radio transmission, reaching Earth at the speed of light. We sent 12 people to another world and brought them home. It remains, in terms of human achievement, something that has not been equaled. Somewhere in the world right now, someone is looking at the moon through a telescope for the first time. Perhaps a child. Perhaps an adult who has never had occasion to do it before. And they are seeing, as everyone sees for the first time, that it is not a smooth disk, but a textured, dimensional, dramatic world. Craters and mountains and valleys visible from 384,000 kilometers away. That the moon has geography. That it is a place. The reaction is always the same. A small sound of surprise and then silence. The moon does that to people. The moon has been your companion your entire life, whether you thought of it that way or not. Before you knew its name, it was already there, already pulling at the water in your body, already lighting your world when the sun turned away. It was there on the night you were born. It has moved through every phase during every year of your life, every 29 and a half days returning to the shape it held when you took your first breath. You have seen thousands of full moons already. There are, perhaps, thousands more ahead. Each one will look very much like the last. That is not monotony. That is constancy. It is not the same thing. The moon will drift farther from Earth over time. In hundreds of millions of years, total solar eclipses will no longer be possible. The moon will have retreated far enough that it can no longer cover the sun's disk from Earth's surface. The coincidence of size and distance that makes those eclipses so breathtaking, that perfect alignment of ratios, is temporary. We happen to live in the epoch when it works. When you stand on Earth and watch the moon swallow the sun, you are witnessing something that cannot happen forever. A brief alignment, like a door open only for a while, and we are walking through it. And you are here, right now, on a planet that has a moon of exactly the right size and distance to do extraordinary things. On a planet whose tilt is stabilized by that moon, whose tides are driven by that moon, whose biology is threaded with the rhythms of that moon. You did not choose this. You were born into it, as every living thing on this planet is born into it. The gravity of another world has shaped the body you sleep in tonight. The water you are mostly made of has felt the pull of that world every day of your life. You are not separate from this. You are inside it. You have always been inside it, in and out. The breath goes, not fast, not urgent. The moon is up there or below the horizon. It doesn't matter. It is moving in its patient orbit either way. It is keeping its face turned toward you, as it has always kept its face turned toward you. The tides are somewhere rising. Somewhere, a horseshoe crab is following a signal laid down 450 million years ago, climbing a moonlit beach. Somewhere, a person is lying where you are lying, breathing where you are breathing, and the moon is shining on them too. You are part of a very large, very old, very quiet thing. You belong to it. It belongs to you. And you can rest now. Everything is still.